Bismillahirrahmanirrahim. Assalamu alaikum dear students. I'm Arif and welcome you all to the next session on the subject of system programming with Linux. Well, today's session is a continuation of the previous session in which we discussed in detail the concepts involved in the internet domain TCP sockets, which provides a reliable, full duplex, stream-oriented communication channel with other features like error detection, flow control and congestion control. We discussed the related socket APIs and have seen some sample client and server programs as a proof of the concept. If you have not seen and understood that session, then today's session is not for you. Please fall back, first see that session and then fall back to this one. This slide shows the agenda of today's session. Well, dear students, if your internet working concepts are weak, you can view my internet working with Linux videos on this YouTube channel. I think there are about 20 videos on this series of internet working with Linux. Okay, so dear students, Datagram sockets, also called the SOC-Dgram, they provide unreliable, full duplex and packet-oriented communication channel. In UDP sockets, messages are transmitted and received in terms of datagrams, which is a small fixed length packet. A process either reads the entire message or in case of error does not read any data. Unreliable means there is no sequence numbering as is there in case of the TCP sockets. So messages may arrive out of order, be duplicated or may not arrive at all. Well, these datagram sockets can be connected as well as unconnected. Let's move ahead and see the sequence of system calls that gets called behind the curtain when a client and server program communicates. Okay, let me describe the sequence of these calls by analogy with the postal system. Well, as there is no connection establishment, a three-way handshake or four-way connection termination in case of UDP sockets is not there. So unlike TCP server, in case of a UDP server, there is only one socket on which all the data transfer takes place with the client socket. So on the server side, there is one socket instead of two. Let's see the sequence of system calls. First of all, the server will make the socket call to create a socket, which is equivalent of setting up a mailbox. Then the server calls bind system call to bind the socket to an IP address and appropriate port number. This step is equivalent to assigning a postal address to your mailbox so that people can send you letters. The server then blocks on recv from system call to receive messages from any client. Let's move on to the client side now. The client also makes a socket call to create a socket. The client then uses the send to call to send a message to the server. On the server side, recv from allows us to obtain the address of the client. Okay, and then after preparing the response, the server uses send to send reply to the client. And this of course continues until a client call close on its socket descriptor. Well, remember, as with postal system, when multiple letters are sent from one address to the other, there is no guarantee that they will arrive in the order in which they are sent. And there is a possibility that they don't arrive at all. Another possibility can be a datagram could arrive more than once when the underlying networking protocol may retransmit a data packet. Okay, well, this is for the unconnected UDP sockets. The client may call connect system call in case of connected UDP sockets. And let me describe this on this slide. Mostly Datagram sockets are connectionless. That is, the client do not call connect. Rather, address every message using send to and require from calls. It is possible for a process to call send to different server processes. In case of a connection-oriented Datagram socket, the client calls connect and specifies the UDP server address. The socket in that case is said to be connected. And from that point onward, the client may only send to and receive from the address specified in the connect call. So the client do not have to use the send to or require from call. He or the client can simply use the send and require or the write and read system calls. Well, this slide shows the pseudocode of sequence of system calls for UDP or Datagram sockets. This gives a comparison between stream and Datagram sockets. Datagram sockets place less load on kernel network code and on network traffic. Datagrams may get lost in transit and they may arrive out of order, as I have already said. And for these two reasons, Datagram sockets are best suited to applications in which simplicity, efficiency, and speed are more important than data integrity and consistency. Well, UDP sockets are a bad choice for web, file, or email servers, as they can be large documents. UDP sockets are good choice for stream of music and video where a missing note or frame may not even be noticed. So keep these points in mind whenever you are deciding whether to use a stream socket or a Datagram socket in the internet domain. Well, this slide shows the lab setup, which is the same as discussed in the previous session. We will be working on the Kali machine and Ubuntu server. And let us now move on to the Linux terminal and see the code of two eco clients that use Datagram sockets, unconnected as well as the connected one. Okay, let me first move on to the Ubuntu server. Let me check out hostname, Ubuntu server, who am I? I'm root, ifconfig, note the IP address 192.168.100.20. And let us confirm if the eco server is running on this Ubuntu server under zinetd systemctl status zinetd. It is not running. Let me run it by giving it a start. And let's check the status again. Well, it is running now. Let's fall back to Kali now and see the sample code of a UDP eco client. I have written it for you to save time. UDP eco client, and let's see the connected UDP eco client first. Well, this program connects to the eco service. Note the change. It is receiving two command line arguments, the IP and the port number. And note the change in the socket call. Over here we have the second argument is sock dgram for a UDP socket instead of sock stream. Then as usual we are populating the sock ADDR in structure. Well, over here note that we have mentioned, yes, over here I have mentioned the first command line argument containing the IP address of the server in the inet underscore a to n function to convert the IP address string to 32-bit binary network byte ordered value. Also note this change over here where I've used the second command line argument arg v sub 2 and I have converted it to integer from ASCII to integer a to I function, and then I have passed this value to host to network short function to convert it from host byte order to network byte order. And then we have called connect, as this is a connected UDP socket. This connect will store the address of the remote socket in the local socket data structure. And remember, no three-way handshake will take place. However, we can now simply use these read and the write system call on this socket. Note that we are using the read and the write call on the UDP socket. And since this is an eco client, we are just reading from std in, writing to the socket, reading from the socket, and writing to std out. Well, dear students, let me tell you one more thing. That is, in case of UDP sockets, you can call connect multiple times to change the association of the Datagram socket. So once you are done with this server, you can call connect again to connect to another server. Hope the concept of a connected UDP socket is clear to you now. Let me save and quit and compile this program. UDP client underscore connected.c. Okay, we have an error near line 22. No, I have used the wrong command. I have to do GCC, so it's success. Let me run it, ./a.out, and give me the IP of Ubuntu server, that is 192.168.100.20, and the port number 7, which is the port number for eco service. And let me say hello world. Oops, it is not working. Why it is not working? Well, there can be a number of reasons. Let us first check if the eco service is running on Ubuntu server. Let me check out on Ubuntu server the status of the sockets -ant, and let me grab 7, and well, yes, it is the TCP. I need to check out for UDP, A and U. Okay, so there is a problem. The eco service is enabled for the TCP, but it is disabled for UDP. Let me enable it by changing the configuration file, and that configuration file of zinetd in @zinetd.d, and the name of the file is eco. And yes, over here you can see the UDP version is disabled. So let me write down no over here, save and exit this file, write down system ctl start zinetd.service. Let me check out now again, netstat -a and u grep 7, and now the UDP service is running on 7. So that is great. Now let's move on to Kali and try again. Let me use up arrow, try again. Learning is fun with Arif, and this time it is working. This is great. Okay, let us confirm one more thing, and that is check if there is 1 or 2 sockets on Ubuntu server. Let me run it again. Let me come out to Ubuntu and see it again. So there is no second socket on the server side. As we have seen in case of TCP, there are 2 servers. Okay, so far so good. Well, dear students, in mostly the UDP sockets are unconnected. That is, the client do not call connect as we have just seen. So to read and write on unconnected UDP sockets, we need to learn 2 more functions, and one of them is send to. Okay. This is the send to function. You can observe send to is passed 6 parameters. The first 4 are the same as in case of send. This 5th is the destination address where we want to send this packet or message, and the sixth one is the size of the address. Do read the man page for details, and let me show you the other call that we normally use, and that is recv_from. And again, you can observe recv_from is also passed 6 parameters, and the first 4 are the same as in case of recv. The fifth one is a pointer to an empty sock ADDR structure. On successful return of this call, you will get the address of the sender in this structure. And the sixth is a pointer to the size of this structure. To read the man page for details and the possible error return values. I think we are equipped to understand the sample code of unconnected or standard UDP sockets. So let me show you the code. UDP Client, and this time this is unconnected. So this is the same piece of code as we have just discussed. One difference is there is no connect call. After this, there is no connect call over here. And the other difference is that instead of write and read, we use send to and recv_from. In case of send to, you can see we are writing data on this socket descriptor, which is there in this buff, and this is the size of the buff, and this is the destination address which we have mentioned over here. And in case of recv_from, we are reading from this socket and placing the data in this buffer, and this time this address will of course contain the address of the client. Okay, let me close this, compile this, echo client unconnected.c 192.168.100.20, and the port number is of course 7, and this is Ramazan, and I am fasting, Alhamdulillah. Let's press Ctrl+C to quit. Okay, so what else? Well, in the last session, dear students, we wrote the TCP daytime client. Let us see its UDP version today. And let us see the RFC 867 of the daytime protocol first. Yes, over here I have the RFC 867 of the daytime protocol. So we have the TCP based as well as the UDP based daytime service, and both return the current date and time as an ASCII string. The TCP based daytime service returns the ASCII string on connection establishment. That is, the client need not to send any data to the server, and the service closes the connection after sending the string. The UDP based daytime service returns the ASCII string on receipt of a message from client, and the data received is ignored. Remember, in case of UDP, since there is no connect, so we need to send data to the server, and of course the server will ignore that data and will return us the daytime string. Do read this page, it's simple. Let's fall back over here, and let's see a sample client program that uses UDP based daytime service running on Ubuntu server, UDP daytime, and remember it is unconnected. Okay, so in the socket call, just note the second argument is sockdgram, that means UDP socket. Then we have populated the address structure over here from the command line arguments, the port number and the IP address, and finally we have used send to send an empty string to the server. Remember, this str contains nothing. We have just sent this to the server, and then we have used the recv_from call to receive the ASCII string containing the date time in this variable buff, and then we have used the printf function to display it on screen. It's very simple. Let's compile and run it. UDP daytime client.c. Let's hope that this service is running over there. and let me use this, and the daytime service port number is 13. Oh, that is great. So we have received the current date and time from Ubuntu server, which is running this daytime service. Well, this discussion will remain incomplete if we will not discuss the time service which runs on port 37. And let us visit the RFC 868. Let me show you RFC 868, the time protocol, to understand the difference between the time and the daytime protocol. Well, dear students, the time protocol provides a site-independent machine-readable date and time in seconds since Internet epoch, that is midnight January 1st, 1900. And we should not confuse it with Unix epoch, which is midnight January 1st, 1970. If I go down, the difference between these two times, that is Internet epoch and Unix epoch, is about 70 years, or this value in number of seconds, that is 2,208,988,800 seconds. Fine. So in case of UDP, this is how it works. The server listens on port 37, the client sends an empty datagram to port 37, server receives the empty datagram, sends a datagram containing internet time as 32-bit binary number, and client of course receives the datagram. Let us move on to the Kali terminal and see sample code that implements this logic that we have just discussed. Let me clear screen, show you vim UDP time client.c. Okay. Okay. So we have created a UDP socket. We have populated the sock ADDR structure with the address of the server, and the IP and the port number we have received via command line arguments. Then we have used send to send an empty message to the time server. Remember, the message is empty. Then we have created a variable of type time underscore t with the name of CT. And we have used recvfrom to receive the number of seconds passed since Internet epoch. Remember, number of seconds passed since Internet epoch, not Unix epoch. And we have received them in this variable CT. Well, over here then I have used N to HL function to convert the 32-bit binary number from network byte order to host byte order. And since it is an internet time and we want to process it on Unix machine, so we need to subtract this value 2208988800 from this CT to convert it to the number of seconds passed since Unix epoch. And finally, to display this time in human readable string, I have used the ctime function, which we have used before, and then of course I have closed the socket. So it makes sense. Let me compile this UDP time client.c and let me run it. ./a.out 192.168.100.20, which is the IP of Ubuntu server on which this time service is running, and the port is 37. I press enter and I get the time. So far so good. So that is great. Okay, so we are done with the client programs, and let's write down a sample server as well using UDP socket. And in the previous session we have used echo, so let me show you the code of UDP echo server. Fine. Okay, so once again we have created the socket, the UDP socket, because I have mentioned sock diagram over here. I have populated the sock ADDR structure. and the port number I have used is 54154, and instead of specifying the specific IP, I have used a constant in addr_any, which is a macro for address 0.0.0.0 to be used for multi-homed hosts. That is a computer with multiple IP addresses. Fine, then I have used bind to bind the socket with this IP address and port, and then the server gets blocked on requi from to receive the data from the client. And since this is an eco server, the server will receive the data in this buff, and then it will use send to send the data back to the client. Remember, dear students, on successful return of this requi from function, the socket data structure will also have the remote IP and port number. The local IP and port number has been populated by us, and the remote IP and port number will be populated by once this requi from function returns. And this, of course, send to will send the data to that socket, and finally we have closed the socket. So that is great. Let me compile and run this program, UDP eco server.c, with the name of, let's suppose, UDP eco server. Fine, and let me copy this to the Ubuntu server machine. Use SCP, that is a secure copy. This is a copy protocol that use the secure shell protocol underneath. We have used it in the previous session as well. UDP eco server, this is the file we need to transfer in the account of root on machine 192.168.100.20, and on that machine the path is the home directory of root, of course. Let me give the password of root for Ubuntu. Of course, I'm not going to tell you, and it is copied over there. Let me confirm. Clear screen, pwd ls, and well, yes, I have UDP eco server over here. Fine. So let me run it. /UDP eco server. So it is running. Let's fall back over here, and let me use the same TCP eco client that I have written before. TCP eco UDP eco client, and let's use the unconnected one, and let me run it, and let me give the address of again 192.168.100.20, the IP of the Ubuntu server, and the port is 54154. So this is it. Oops. Yes, it has returned once and not the next time. Okay. So the reason is I have not used the while loop over there. Let me correct this. Server.c. Fine. Just I have to enter a while one loop over here, so that this thing should be repeated. Let's compile it again. UDP eco server.c UDP eco server, and let's copy it using the same command. Fine, and this will of course be overwritten over here. Let me run this new program, and let's run this now again, and let me see again. It works. So this is it, and this works. Bye bye, students. Let me press Ctrl C over here. Let me press Ctrl C over here, and Let us fall back to slides to see if there is anything which is left. So we have talked about send to, we have talked about directly from, UDP daytime client we have written, UDP time client we have written, and UDP eco server we are done with this as well. Okay, so today again we conclude with an assignment. Dear students, please study the famous Unix NC netcat utility, famously known as the TCP/IP Swiss Army knife. Excuse me. Try to dig out its features to see what does netcat do. Then try to understand how does netcat do it. And finally see if you can write a basic version of netcat at your own. So with this I come to the end of today's session. Inshallah, in the next session we will talk about Unix domain sockets for both TCP as well as UDP sockets. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. Happy learning and Allah Hafiz.